Hello everyone. It's a great honor for me to speak at this meeting. I'm Li Ruiyang, a PhD student from Hunan University. Since 2018, I have studied DA under Professor Zhu Zhongbao. In this video, I would like to share with you about some of our recent work. Name of our paper is Dynamic Performance Evaluation of Blockchain Technologies. This paper mainly introduced two parts of work. One is to propose a new indicator system for performance evaluation of blockchain technology, and the other is to propose an improved global DEA Manquist index without implicit inputs to assess the dynamic performance of blockchain technology. I will give this talk in four parts. The first part deals with the background of our research. The second part introduces the methods involved in this paper. Third part shows application and empirical analysis results. Then the last part is a summary. As we know, blockchain is a distributed ledger that provides verifiable proof of a transaction between sender and receiver. 2008, Satoshi Nakamoto released a white paper establishing the model for a blockchain. Next year, Nakamoto implements the first blockchain as a public ledger for transactions, which is named Bitcoin. Later, blockchain technology is separated from the currency and its potential for other financial, interorganizational transactions are explored. 2014, Blockchain 2.0 is born, referring to applications beyond currency. The ETH blockchain system introduced computer programs into the blocks, representing financial instruments such as bonds. This became known as a smart contract. As of August 2019, the number of blockchain projects promoted by governments reached 154. Essentially, a blockchain project is an integration of many technologies, such as distributed data storage, peer-to-peer transmission, and so on. At the same time, blockchain is widely used in many fields, many involving the financial industry, government archives, digital asset management, voting, and so on. But why do we need to evaluate blockchain technology? According to the blockchain white paper released by CAICT in 2019, there are no less than 2,000 blockchain or blockchain-related projects in the world now, and the number is still increasing. At the same time, for companies, individuals, it costs money to replace the blockchain projects they use. For example, they need to re-upload data, deploy equipment, etc. Or, even worse, a poorly performing blockchain project may shut down one day. All this will cause trouble for users. So, it is necessary for us to choose the best performing project from very beginning. There are many researchers on blockchain that are not listed here. Most of them focus on computer, theory, algorithm, etc. However, this research focuses on performance evaluation. Recent years, there are few studies focused on this area. CCID released the first global public blockchain technology assignment index in May 2018. Although Bitcoin is the most popular one, its technology still has limitations, so its ranking is not high. Later, Tang designed a two-level indicator system to evaluate the public blockchain and rank the public blockchain by using top Cs. The following content will focus on these 3 points: an indicator system, a dynamic evaluation method, and an empirical analysis. The indicators include 3 aspects: technical indicators, market indicators, and popularity indicators. For technical indicators, all 3 sub-indicators are from CCID. We will introduce them later. Market indicators, recent years, there have been more and more criticism of virtual currencies. But market performance still can well reflect investors' expectations of blockchain projects. And popularity. The popularity directly determines the resources and participants a blockchain project can obtain. So, this indicator is also very important. From Figure 1, we can see the structure of the index system. It will help us evaluate blockchain technology comprehensively. Next, let me introduce each indicator one by one. Let's start with technical indicators. We can see Y1, Y2, Y3. All 3 indicators are from CCID. For Y1, Basic Tech, it focuses on blockchain's realization function, basic performance, security, and centralization degree. Y2 represents application status of blockchain technology. Consider application scenarios, number of wallets, and so on. Y3 creativity evaluates innovation status, inspects innovation team, code update frequency, code influence, and other aspects. Then, its market indicator. We use the monthly mean of daily returns, Y4, and monthly standard deviation of daily returns, B1, to examine the market performance of blockchain projects. Y4 represents the profitability of virtual currencies. B1 represents the stability of profitability. It should be noted here that the monthly standard deviation of daily returns, B1, is an undesirable indicator. The smaller the value of this indicator, the better the virtual currency performance. In addition to the above indicators, public sentiments towards blockchain projects also affects the development of blockchain projects. In the search market, Google has around 90% of searches worldwide. The popularity of search terms over time and across various regions of the world can be compared in Google Trends. We use the average Google Trends hit Y5 of a public blockchain to reflect the popularity of this blockchain. Before introducing our index, let's review the traditional Global Manquist Index first. The concept of the Global Manquist Index was first introduced in 2005. This index specifies global benchmark technology with data of all DMUs in all periods. Specifically, they define contemporaneous benchmark technology for period T as TT, and define the global benchmark technology as the convex envelope of all contemporaneous technologies. For example, TG is the union of all TIs. Then, the Manquist index is defined as M, which is the geometric mean of these two ratios. So, the global Manquist index on TG is defined as MG. We can see the output distance function DG is defined as follows. The decomposition of Manquist index can provide us with more information. We can see the process on the slide. EC is the efficiency change between period T plus 1 and period T. BPG represents the biggest gap between TS and TG measured along with XS, YS. BPC shows the change between BPGs. By observing the BPC, we can see how the benchmark technology is moving from T to T1. If BPC is less than 1, that means the benchmark technology is moving farther away from the global benchmark technology from T to T1. When it is bigger than 1, that means it's getting closer. And when BPC equals to 1, means there's no change from T to T plus 1. Well, blockchain projects are different from traditional production process. The traditional production process have detailed inputs such as capital, employees, equipment, and so on. However, when it comes to blockchain technology, inputs are often not explicit. Offices, funds, and equipment may not be the most important thing. And what really matters, like talented engineer, time they spend programming, we will never know. So instead of focusing on the ratio, like output divided by input, we pay more attention to efficacy and effectiveness of blockchain technologies. Similarly, we make the following definitions. We focus on desirable and undesirable outputs. So we have set ST here. Also, we have SG, the union of all SI. The definition of M, MG are all similar with P's definition. When considering only desirable and undesirable outputs, we define DDF on global technique and takes the specific form as DG. Since the global DDF utilizes all blockchains over all periods in constructing the PPS, when computed for blockchain 0 at period T under VRS assumption, the model is shown on the slide. We also have EC for efficiency change. The closeness of the frontier of period S and the global frontier can be represented by the ratio. Then we can get TC, which shows the frontier change from T to T plus 1. And then this new Marquis index can also be decomposed into EC and TC. Because all DMUs evaluated refer to the same global reference set, this Marquis index does not have the infeasibility problem. Because each period represents a common global frontier, this Marquis index is transitive. That means MG21 times MG32 equals to MG31. In this section, we applied the modified GM index to assess 31 public blockchains' performance from May 2018 to April 2020. We have 31 DMUs, all of them are famous blockchains. We have 6 indicators, 5 desirable and 1 undesirable. Next, let's see the results from our calculation. By changing the frequency, we got 3 sets of results. Due to limited space, specific GM, EC, TC data are not shown here. From figure 2 to 4, we can roughly observe the data distribution. Bitcoin and ETH are the 2 blockchain projects that people are most concerned about. Bitcoin has 14 GM that are greater than 1, while ETH have 15 GM that is greater than 1. The efficiency change of 2 blockchain projects is 1, and by looking at global efficiency of these 2 projects in each period, we find that they have their own advantages. Bitcoin is always the hottest, while ETH does better in technical indicators. Therefore, they have the highest overall efficiency in each period, which is 1. This makes sense, since GM is equal to EC times TC. In this case, where EC is equal to 1, the GM changes of both projects comes from TC. From this slide, we can see that most of blockchain projects have improved throughout the observation period, and the top 5 with largest average improvement are IOAT, Zcash, Hcash, XLM, and NEOLS, while GM of NEO and other 4 blockchains are all less than 1. That means these blockchains have experienced different degree of regression. Among them, the GM of EOS and ETH are both 1. There is no obvious improvement or regression from period 1 to period 24. Bitcoin performed well in this evaluation. Mean GM is 1.018. From the decomposition of GM, we can see that Bitcoin's progress mainly comes from TC. The mean EC of Bitcoin is equal to 1. Table 2 gives more detailed information. In 2 periods, May 2018 to November 2018, and May 2019 to November 2019, many DMUs have a GM index of less than 1. In the second half of 2018, the CBIRC and other 5 ministries and commissions jointly issued the reminder on the risk of illegal funds raising in name of virtual currency and blockchain. At the same time, many countries have adopted a series of regulatory measures against the ICO projects. These policies have caused a short-term negative impact on the development of blockchain. In the second half of 2019, the headquarters of People's Bank of China further strengthened the supervision of ICO projects. In the past, blockchain projects used cryptocurrency as a main reward mechanism. With the increasingly strict supervision of virtual currency transactions in countries around the world, blockchain projects have been directly and negatively affected in terms of market performance and popularity. In terms of technical indicators, due to the impact of negative news during those 2 periods, the basic technology, applicability, and creativity also declined. The other 2 stages only have 2 blockchains each, with a GM index less than 1. Combined with the overall situation, 2 periods of regression may be caused by the transformation of blockchain technology from ICO-oriented to application-oriented. In this paper, we try to provide a dynamic evaluation method for user selection process. First, we proposed a blockchain technology performance evaluation indicator system. Then, we modified GM indicators for special situations. And finally, we applied the method to evaluation and get some interesting results. Okay, everyone, it has been my pleasure to share with you. Thank you very much for your kind attention. Goodbye.